A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. You know, everyone talks about retrieval or augmented generation like it is this magical infinite brain for your company. But the second you mention the word budget, the room goes silent. It is like the Voldemort of AI implementation. People just assume it is either basically free because API calls are cheap, or it is going to bankrupt the department because vector databases are expensive.
It is a classic case of the prototype trap. You build a RAG system over a weekend using 100 PDF documents and your personal OpenAI key, and it costs you about 4 cents. You think, great, let's scale this to the entire corporate knowledge base. And suddenly you are looking at a bill that has 4 extra zeros at the end and no one can explain why. Today's prompt from Daniel is about exactly that, pulling back the curtain on the actual, cold, hard cash required to run these systems in 2026.
And we are going to get into the weeds today. We are talking raw embedding costs, the storage tax of vector databases, and that hidden killer, reindexing. By the way, quick shout out to our scriptwriter for the day. Google Gemini 3 Flash is handling the heavy lifting on the composition side for this episode.
It is fitting, honestly, because the model landscape is a huge part of this cost equation. When we look at where we are in March of 2026, the pricing has stabilized in a way that makes it look almost like a commodity market. But as we will see, cheap is a relative term when you are talking about millions of documents.
Right, so let's start with the entry fee. To get a document into a RAG system, you have to turn it into a vector. You have to embed it. If I'm a small team and I've got, say, a company Google Drive with 10,000 documents, which is a pretty standard starting point, what is the actual cost to just get that initial index built using something like OpenAI?
Well, let's look at the benchmark for March 2026. OpenAI's text embedding, 3 small, is sitting at about 2 cents per million tokens. Now, to put that in perspective for the listeners, a typical document is maybe 5,000 tokens if it is a meaty internal strategy paper or a long technical spec. If you have 10,000 of those, you are looking at 50 million tokens. At 2 cents per million, your total bill for the initial embedding of that entire drive is $1.
Wait, hold on. $1? That is it? I've spent more on the coffee I drank while waiting for the script to run.
For the raw API calls to the small model, yes, it is effectively rounding error for a small team. This is why people get lulled into a false sense of security. They see that $1 bill and think, AI is basically free. But even if you move up to a more sophisticated model like Cohere's Embed English v3.0, which is roughly 10 cents per million tokens, you are still only looking at $5 for those 10,000 documents.
Okay, so if embedding is that cheap, why is anyone complaining? There has to be a catch. Is it the tokenization? Because OpenAI charges per token, not per document. Does the way we chunk the data change the price?
Not directly in terms of the API cost, because 50 million tokens is 50 million tokens, whether it is in one big block or 1,000 small chunks. But the mechanism of cost at scale starts to shift when you look at the enterprise level. Let's scale that 10,000 document drive up to an enterprise corpus. We are talking maybe 10 million documents. Internal wikis, years of emails, Slack archives, technical documentation. Now we are looking at 5 billion tokens.
Okay, let me do the math. 5 billion tokens at the 2-cent rate for OpenAI's small model. That is $100. Still feels like nothing for a Fortune 500 company.
It is $100 for the small model, but here is where the quality versus cost trade-off hits. For an enterprise-grade system, you usually aren't using the small model. You're likely using something more robust, or perhaps a specialized model for your industry. If you jump to a high-end proprietary model or a large-scale re-ranker, those costs can climb. But even then, the raw API cost is rarely the thing that breaks the bank. The real enterprise cost problem comes when you realize that 5 billion tokens isn't a one-time fee.
Because documents change?
Because documents change, and because of vector debt. Every time you change your embedding model, maybe a better one comes out in 6 months. You have to re-index everything. If you are an enterprise and you decide to switch from OpenAI to a self-hosted open source model like a highly tuned BGE or an E5 model, you have to reprocess those 5 billion tokens. If you do that 4 times a year as the tech evolves, those cheap API calls start to look like a recurring subscription you didn't sign up for.
I love that term, vector debt. It is like technical debt, but specifically for things that live in a multi-dimensional space. So, if I'm that enterprise and I realize I don't want to keep paying the API tax, or I have data privacy concerns, I look at self-hosting. What does the math look like if I run my own embedding server on something like Modal or my own hardware?
This is where it gets really interesting. If you go the self-hosted route using commodity hardware, say a few A100s or even the newer T4s for smaller models, your per token cost drops to almost zero, but your infrastructure cost spikes. For that 5 billion token enterprise corpus, you could probably process the whole thing in a few days on a cluster that costs you maybe $500 in compute time. Compare that to the thousands you might pay for premium API tiers, and the break-even point for large datasets happens much faster than people realize.
But you need an engineer to set that up. You need someone to manage the Triton inference server, handle the batching, and make sure the GPU doesn't melt. That engineer hour cost is probably the biggest hidden fee in the self-hosted model.
You hit the nail on the head. For a small team, spending 3 days of an engineer's time to save $50 on OpenAI calls is a fireable offense. But for the enterprise with 10 million documents, spending that same engineer's time to save $50,000 a year in recurring API and re-indexing costs is a no-brainer.
Okay, so we have established that generating the vectors is surprisingly affordable if you pick the right model for your scale. But that is just the ingestion phase. Once I have these 5 billion vectors, I can't just leave them sitting in a text file. I need a place to put them. This is where the vector database enters the chat, and I have heard this is where the real sticker shock happens.
This is the vector DB hangover. When you look at managed services like Pinecone, Weaviate, or Milvazilla's, you aren't paying per token anymore. You are paying for storage and compute. And unlike a standard SQL database where storing a few gigabytes is pennies, vector storage is memory intensive.
Why is it so much hungrier for resources? It is just numbers, right?
It is the indexing structures. To make a nearest neighbor search fast, so you aren't scanning every single vector every time someone asks a question. The database has to build complex graphs like HNSW, which stands for Hierarchical Navigable Small World. These graphs need to live in RAM to be fast. RAM is expensive. If you have 10 million vectors, and each vector has 1,500 dimensions, which is standard for OpenAI, that is a massive amount of high-speed memory you need to keep hot 24/7.
So, give me the numbers. What does it cost to keep those 10 million vectors alive and searchable in a managed service?
In 2026, for 10 million vectors on a managed service like Pinecone with a high-performance index, you are looking at roughly $500 to $800 a month. That is your rent.
Oh, wow. So for the small team with 10,000 documents, it might be $50 a month. But once you hit enterprise scale, you are paying $10,000 a year just for the privilege of having your data ready to be searched.
At least. And that doesn't even include the query costs. Every time a user asks a question, the system has to embed the question, which is cheap, and then perform the search in the database. Managed providers usually charge per compute unit or per 1,000 queries. If you have a popular internal tool with thousands of employees asking questions all day, your query bill can actually overtake your storage bill.
It is like owning a car where you pay a monthly fee to keep it in the garage, and then a fee for every mile you drive. And oh yeah, you also paid to have the car built in the first place.
And don't forget the re-indexing fee. Let's say you realize your chunking strategy was bad. You were cutting sentences in half, so the AI is giving garbage answers. You have to delete everything in the database and re-embed and re-upload all 10 million documents. Not only do you pay the API cost again, but the database provider might charge you for the write-heavy operation of rebuilding the index. We are seeing re-indexing costs for large datasets hit between $12 and $40 per 10 million vectors just in compute overhead.
I think this is the part where people's eyes start to water. It is the ongoingness of it. It is not a project you finish. It is a utility bill you pay forever. But let's look at the flip side. If I am a mid-sized company, let's say 50 employees, 1 million documents, and I don't want to pay Pinecone $500 a month, can I just run a vector database on a standard server? Is VectorDB as a file a real thing?
It absolutely is. This is the single file movement we have seen gain steam lately. For 1 million vectors, you can actually use something like Fayus, or even just a local instance of Chroma or LanceDB. If you run that on a standard AWS EC2 instance, maybe a T3.large, which costs about $60 a month, you can handle 1 million vectors with decent latency.
So the mid-company sweet spot is really about moving away from the all-managed expensive stuff and moving toward managed light or self-hosted infrastructure.
A mid-sized company can use OpenAI for the embeddings, costing them maybe $10 for the whole 1 million document set, and then run their own database for $60 a month. Total OPEX, $70 a month. That is a massive difference from the $500 plus bill you get from the high-end enterprise providers.
It feels like there is this valley of death in RAG pricing. Small teams are fine because they are in the free tiers or spending pennies. Enterprises are fine because they have the budget and the scale to build custom infra. But the mid-sized guys get stuck in the middle, paying enterprise prices for prosumer needs because they don't have the DevOps staff to self-host.
That is where the market is most competitive right now. We are seeing providers offer serverless, vector databases where you only pay when you actually run a search. If your internal RAG tool only gets used during business hours, serverless can drop your monthly bill from hundreds of dollars to literally $5.
That is a huge takeaway for anyone listening who is currently looking at a fixed monthly quote for a vector DB. Check if there is a serverless option. If you aren't searching 24/7, you are paying for idle RAM, which is the most expensive thing in the cloud.
It really is. And since we are talking about budgeting, we should mention re-ranking. This is the hidden stage 2 of RAG that people always forget to budget for.
Re-ranking? Is that like the fact checker after the search?
Chulos. Standard vector search is fuzzy. It finds things that are mathematically similar but not necessarily correct. A re-ranker takes the top 20 results and uses a much more expensive, much smarter model to say which of these actually answers the user's question.
And let me guess, it is not 2 cents per million tokens.
Not even close. Re-ranking can be 10 to 50 times more expensive than the initial embedding search because it is essentially running a mini LLM inference on every single search result. If every query re-ranks 20 chunks, your cost per query just jumps significantly. For an enterprise, this can be the difference between a RAG system that costs $200 a month and one that costs $2,000.
It is amazing how cheap embeddings are the bait that gets you into the expensive infrastructure trap. It is like a printer where the machine is $50, but the ink is 1,000.
But I don't want to sound too pessimistic because when you compare these costs to the alternative, they are still a bargain. What does it cost to have 5 human librarians who know every document in your company and can answer questions instantly?
Well, in 2026, a human librarian likely costs $100,000 a year plus benefits, so even a pricey RAG system at $20,000 a year is an 80% discount.
This is the argument that wins over the CFO. You don't compare the RAG bill to zero, you compare it to the cost of ignorance. How much time is wasted by engineers looking for a spec that already exists? If you save 10 engineers 2 hours a week each, you have already paid for the most expensive enterprise RAG system 10 times over.
That is the value metric we should be talking about. But let's get back to the actual numbers for a second, because I want to make sure people have these ballpark figures in their heads. If I am the small team, under 10 people, 1 million documents, what is my monthly burn?
Small team, use OpenAI text embedding, 3 small, and a serverless vector DB. Total initial cost to embed $10. Monthly recurring cost may be $20 to $30 for storage and queries. It is basically a Netflix subscription.
Mid-size company, 50 to 100 employees, 10 million documents.
Mid-sized, use a hybrid approach. Maybe use Cohere for embeddings because their compression features reduce your storage bill. Use a managed but tier-based vector DB. Initial cost to embed $50 to $100. Monthly recurring $300 to $500. Still very manageable for a company with a few million in revenue.
And the enterprise behemoth, thousands of employees, 100 million documents across 50 different departments.
This is where you go full custom stack. Use self-hosted open source embedding models on your own GPU clusters to avoid the API tax. Use an open source vector DB like Milvus or Weaviate on your own Kubernetes cluster. Initial cost to embed may be $5,000 in compute and engineer time. Monthly recurring $2,000 to $5,000 in cloud infra costs.
It is interesting that at the enterprise scale, the price per document actually drops significantly if you have the talent to manage it yourself. The tax is really on the people who need the easy button.
It always is. But the easy button is getting cheaper too. We are seeing things like VPC integrated, AI services from AWS and Google, where the embedding and the storage are bundled into your existing cloud agreement. Sometimes you can even use your committed spend credits on it, which makes the actual cost to the department feel like zero.
I want to touch on one more thing before we wrap up the cost section, the multimodal shift. We are not just embedding text anymore. People want to search images, videos, and audio. Does the math hold up there?
The math gets way more aggressive. Embedding an image using a model like Clip is more computationally expensive than text. And if you are doing video where you might be embedding one frame every second, you are essentially turning a 10-minute video into 600 documents. Your vector count explodes. If you aren't careful, video rag will eat your budget in a weekend.
So the lesson there is, don't embed everything just because you can. Be surgical.
Precisely. The smartest budget first. RAG teams are the ones who spend the most time on data cleaning. If you remove the duplicates, the old versions, and the garbage lunch menu PDFs from your index, you aren't just making the AI smarter, you are directly lowering your monthly bill.
It is the first time in history where tidying up your files has a direct, measurable ROI on the company's cloud bill.
It is a great motivator. Clean your digital room or we lose $500 this month.
Alright, let's talk practical takeaways. If someone is sitting there right now with a mandate to build a RAG system and a limited budget, what are the 3 things they should do to avoid the vector DB hangover?
First, start with a serverless vector database. Do not sign up for a fixed tier starter plan that charges you $200 a month while you are still testing. You want to pay for the 3 queries you run today, not the capacity for 10,000 queries you aren't making yet.
Second, use the small models first. People always want to use the best model, but for 80% of internal company documents, the difference between OpenAI's small and large embedding models is negligible for retrieval, but the storage cost for the large vectors is double because of the higher dimensionality.
That is a huge one. Higher dimensions equal higher RAM requirements in the DB. If you can get away with 768 dimensions instead of 3072, your database bill literally drops by 75%.
And third,
plan for reindexing from day one. Don't build a system where re-uploading your data is a manual, painful process. Automate your pipeline so that if a new model comes out, or if price drops again next year, you can flip a switch and update your entire index for a few bucks without needing a month of dev time.
it is basically agile for vectors. Stay flexible, stay small, and don't pay for RAM you aren't using.
And keep an eye on the open source world. The gap between proprietary API quality and self-hosted quality is closing so fast that by the end of 2026, the API tax might be something only the smallest teams are willing to pay.
It is a fascinating landscape. It is one of those rare moments in tech where the new, shiny thing is actually getting cheaper and more efficient at the same time it is getting more powerful. Usually, you have to pick 2.
It is the benefit of the vector gold rush ending. The companies that survived are now competing on efficiency and cost per query, rather than just look at this cool thing we can do. It is a buyer's market for AI infrastructure right now.
Which is great news for Daniel and everyone else out there trying to justify these builds. You can actually go to your boss now and say, for the price of a mid-range sedan, I can give the entire company a collective memory.
And if you do it right, you might even have enough left over for that coffee Corn was talking about.
Maybe even a fancy latte with oat milk.
Let's not get crazy. The budget isn't that big.
Fair enough. Well, I think we have covered the full spectrum here, from the $1 Google Drive to the $10,000 enterprise cluster. It is not free, but it is certainly not the money pit that some of the early hype made it out to be.
It is all about the engineering. If you treat it like a serious piece of infrastructure, you get serious ROI. If you treat it like a toy, you get a toy-sized hole in your wallet.
Well said, Herman Poppleberry. I think that is a wrap on the real-world costs of the RAG era. Before we go, big thanks to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes.
And thanks to Modal for providing the GPU credits that power the show's research and generation. They are a great example of that pay for what you use model we were just praising.
This has been My Weird Prompts. If you found this cost breakdown helpful, do us a favor and leave a review on whatever podcast app you're using. It actually helps more than you'd think to get this into the ears of other people trying to navigate the AI budget wars.
We are also on Telegram. Just search for My Weird Prompts to get a ping whenever a new episode drops.
Catch you in the next one.
See ya.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth.